With all new info about space coming in on a daily basis, we can't help feeling that there is nothing in the universe we don't know already. Still, in spite of the advanced capabilities of today's technologies and research equipment, there is still quite a big blank spot. Incidentally, it is our own Earth. Thousands of years of investigating the blue planet gave mankind a comparatively meager knowledge about certain phenomena on it. And now I invite you on a brief expedition where we'll take a look at some of the most unusual places and phenomena on the planet. Thus, the Kola Super Deep Borehole will get us to the Earth's interior. Then it will be the turn of permafrost to be checked out, followed by the Bermuda Triangle, the biggest meteorite ever to have dropped on the surface of our planet, global extinctions, and the most dangerous asteroid ever detected. A fascinating trip is up ahead. Let's get started.
Cosmo.
The first in outer space. People have attempted to drill holes in the ground since the 13th century. The main purpose for such projects was to take a close look at a diversity of objects as yet not known to science that could lie concealed in the depths of our Earth. For example, several years ago, a team of geochemists from Russia, France, and Germany discovered an underground ocean dating back to the Archean Eon. It lies approximately 500 kilometers deep, and its volume beats the overall amount of water of all oceans on the planet's surface. This discovery provided scientists with more accurate data about the peculiarities of our planet's formation. There is no doubt that these discoveries would have been unthinkable without super deep drilling projects. One of the best examples of these is the Kola Super Deep Borehole, which maintains the title of the deepest in the world even a quarter of a century after it was closed. The construction and development of the Kola Borehole facility started back in 1970 and continued for over 20 years. Its depth reaches 12,262 meters. The diameter of its opening measures 92 centimeters. The drilling was carried out using the Uralmash 4A drilling rig, to be later superseded at 7,263 meters by Uralmash 15,000, whose mass was over 200 tons. Notably, it took about 18 hours for the column to travel all the way up or down. The chosen drilling site was located 10 kilometers to the west from the town of Zapolyarny. The borehole is situated in the northeastern part of the Baltic Shield and reaches Archean ore-bearing rocks, which are typically to be found in ancient bedrocks of the continental crust. The site is by all accounts ideal for super deep drilling, as the Kola Peninsula is one of the few continental places on Earth that contains no sedimentary rocks and whose surface is comprised of exceptionally ancient rocks dating back approximately 3 billion years. Unlike other major super deep man-made wells made for the purposes of oil and gas extraction works or geological surveys, the object of drilling the Kola borehole was specifically for scientific purposes to pursue research tasks. Its main objective was to confirm theoretical models of the composition of the lower layers of the Earth's crust and to find out more about the nature of their transition to the Earth's mantle. The explorers were also going to find out about the bedrock composition of the Nickeliferous Pechanga complex, identify the special features of geological processes manifestations, and collect more data about the thermal regime in the crust, as well as about deep water solutions, gases, and rock composition. The project was also supposed to help improve super deep drilling techniques already existing at the time and work out methods of complex geological and physical studies of rocks and ores at great depths. The drilling works started on May 24, 1970. It was plain sailing down to 7,000 meters as the drill was passing smoothly through solid homogeneous granite rock. However, having broken through the 7,000-meter mark, the drill entered less solid stratified rocks, and the well scarred and formed voids. The column would then fail, and the drill would detach itself and fall when its recovery was attempted. These failures became regular occurrences, and soon the well's structure assumed a shape reminding one of a tree with multiple branches broken off. On June 6, 1979, the Kola Super Deep borehole beat the 9,583-meter record previously held by the Bertha Rogers oil exploratory well in Oklahoma, and in 1983, the depth of the borehole reached 12,066 meters. After this record was beaten, the drilling was for a short time suspended. When the process was resumed several months later, the first major failure occurred, and the drilling had to be started again from a point just 7 kilometers deep. By the year 1990, the new hole reached as far down as 12,262 meters. However, following several other major failures, the process had to be aborted, with the borehole closing for good 4 years later. It was initially expected that the Kola borehole would be instrumental in discovering clear-cut transition from granite to basalt. It should be mentioned that due to high pressure and high temperatures, the granite rock's physical properties were dramatically affected. The granite samples extracted from the well would often crumble due to the sudden changes in the pressure. Only extremely slow lifting of the drill made it possible to extract a solid piece of rock, which enabled scientists to make quite a few valuable conclusions about the Earth's deep interior. The major result of the geothermal studies was information about temperatures in the well. The indicators proved to be much higher than initially expected. Closer to the surface, the rate of temperature increase accounted for 11 degrees per kilometer. At the depth of 2 kilometers, it grew to 14 degrees per kilometer. At the depth from 2.2 to 7.5 kilometers, the temperature grew at the rate close to 24 degrees per kilometer. Eventually, the temperature of 70 degrees Celsius was registered at the depth of just 5 kilometers, and by 12,000 meters, the temperature rose to as much as 220 degrees Celsius. New practical information about the composition of the deepest parts of the Baltic Shield greatly complemented theoretical suppositions. Analysis of super-deep rocks revealed data considerably differing from information known to science before the launch of the super-deep borehole project. Scientific results were also of practical use. For example, shallow copper and nickel zones were discovered by geologists, and these rocks were suitable for extraction. At the depth of 9.5 kilometers, an anomalous geochemical layer of gold was discovered. Gold concentration accounted for up to a gram per 1 ton of the rock, and even though gold mining is hardly feasible at that great a depth, the very existence of the gold-carrying layer, as well as its properties, allowed modeling evolution processes of these metals with more precision. The length record of the Kola super-deep borehole was beaten only recently, and that only by wells drilled for large-scale oil and gas extraction. One of these is the oil well known as Maersk Oil BDO4A. It was drilled in 2008 and is 12,290 meters long. To date, the Z42 Chivo well is the longest well on Earth, extending as far down as 12,700 meters. However, the Kola borehole remains the deepest man-made well. In addition to the borehole's record-breaking features, it also boasts unique history, which over the years has been shrouded by innumerable legends and mysterious myths. Many of them were prompted by various failures the scientists had to face, but were not always able to identify what had caused them. For example, in 1995, an explosion of inexplicable nature originated at the deepest point of the well, and the drilling had to be stopped. The cause of this phenomenon has never been identified. The supervisor of the operations, David Mironovich Guberman, confirmed that a bizarre noise had been heard prior to the explosion. Interestingly, several days later, nothing of the kind took place at the same depth. It is possible that the cause lay in a failure of the drill itself, or else an encounter with a substance not yet known to science. It is hardly unfeasible, as such deep layers of the globe still remain almost unexplored. The Kola super-deep borehole has traveled only a minuscule portion of the whole way to the center of the Earth. The full distance is 6,371 kilometers. The scientists working at the well hoped to get to the mantle at least, but to achieve this it would have taken another 30 or 40 kilometers. But even as it is, what they did manage to carry out borders on fantasy. To this day, not a single apparatus has gone that deep underground. Today, geology is advancing on a par with space exploration, and research involving drilling is comparable to space exploration using telescopes, which is so familiar to us. Geologists cherish some ambitious plans too, and while one part of the scientific community concerns themselves with how to reach other planets, another part studies the makeup of our own Earth and is busy figuring out how to get as far as its center. Permafrost is the part of the upper layer of the Earth's crust characterized by sub-zero temperatures of rocks and soils which never thaws. The name is self-explanatory if you look at it closer. The total area of permafrost on our planet accounts for 35 million square kilometers. Just to compare, it is 5 million more than the area of Africa. Most of permafrost is to be found in the northern parts of America, Europe, Asia, and the Antarctic. Interestingly, there is not a speck of it in Australia. The temperature in the permafrost soils and rocks never rises above zero, with the depth of the layer sometimes reaching more than 1,000 meters. The deepest point of permafrost is registered in the upper waters of the Vilui River in Yakutia. The record deepest point is 1,370 meters down below. It takes a rather long time for a layer of permafrost this thick to form. Just to give you an idea, it takes one winter for the ground to freeze approximately 1 meter deep. Assuming winter never gave way to spring, the ground would freeze 4 meters deep in the course of 1 year. However, the bigger the depth, the slower the ground freezes, and it would take about 1,000 years for the layer of permafrost to reach as deep down as 116 meters, and about 1,000,000 years to reach a depth of 700 meters. Permafrost is a global, large-scale phenomenon covering not less than 25% of all land on the globe. At the same time, most of permafrost today is slowly but inexorably thawing, and this process will realistically cause staggering damage to the world economy. It is believed that by the end of the 21st century, the thawing will have led to damages worth $43 trillion. It is the increased rate of global warming, with the destruction of the foundations of constructions and areas with permafrost as one of its direct consequences, that may become the chief reason for such damage. Still, all this may be realistically prevented if mankind takes necessary measures to curb global warming and its harmful effects as soon as this century. Incidentally, this danger is not the worst that may befall humankind if permafrost melts. There are other threats lurking in permafrost that may manifest themselves literally at any moment. For example, it may contain frozen viruses whose age may be tens of thousands of years, or else it may cause outbreaks of more recent diseases like plagues of different sorts, including Siberian plague, also known as anthrax. In 2014, Russian and French scientists discovered a giant virus called Pithovirus sibericum, comparable with bacteria in terms of its size. The find was made in 30,000-year permafrost. It proved to be viable, but fortunately wasn't dangerous for humans. The virus preferred exclusively some kinds of amoebas to parasite on, and even the worst-case scenario wouldn't seriously affect the local ecosystem. Still, such frozen finds may theoretically cause small-scale outbreaks of diseases among some animals. Thus, there may be a correlation between occasional outbreaks of the so-called PDV and thawing of ice. As a result, thousands of seals in the Arctic and sea otters in Alaska have fallen prey to the virus for several years with astonishing regularity. Besides, in the past, when there was an outbreak of an epidemic in northern areas, animal carcasses used to be dumped underground. Today, when they thaw, these burial sites pose a grave threat to us, no pun intended. Diseases like a plague may suddenly start spreading at any moment. For example, there was an outbreak of Siberian plague in 2016 in the Yamal region of the Russian Federation. At the time, this phenomenon was largely associated with the anomalous heat wave that year, which caused an animal burial site to thaw, with the virus escaping from its centuries-long confinement. But it is not only Siberian plague spores that are to be found in permafrost. For example, in 2007, French scientists unearthed microorganisms which were still quite active and none the worse for their age, that could be anything up to 500,000 years. One more example. In 2018, some bacteria were discovered in the interior of the frozen Mammoth Mountain in Yakutia. Their possible age is estimated at 3.5 million years. Today, in every permafrost area, such prehistoric burial sites are paid close attention to, and measures are taken to make these territories unavailable to people and animals. Outbreaks of viral infections of this kind are comparatively unlikely dangers, as humanity has had to cope with similar epidemics before. But there are other secrets concealed in permafrost. One of them is the formation of gas hydrate fields, and in particular, methane hydrate. This is a supramolecular kind of compound consisting of methane and water which is resistant to low temperatures and extreme pressure. Methane hydrate, also known as methane clathrate, is the most widespread gas hydrate in nature. Its fields are estimated at 10 to the power of 16 kilograms, which is even more than global oil reserves. These are as big as 2 times 10 to the power of 14 kilograms. Methane is known as one of several greenhouse gases, and the result of its release could be one of the things causing global warming. Still, its effect on the process is not as serious as that of other greenhouse gases like water vapor or carbon dioxide. The point is that methane stays in the atmosphere only for 10 or 12 years. Nevertheless, if in theory methane were to be released from all deposits in the world, it would cause temperatures to soar and all other hydrates to destabilize. This would unleash an irreversible process rapidly gaining in intensity, as irreversible as a gunshot after the trigger has been pulled. The direct result of permafrost thawing is the release of methane into the atmosphere and a gradual build-up of the greenhouse effect. After that, the average temperature on the Earth will increase, which will cause the release of greenhouse gases all over the planet. This will naturally make permafrost thaw quicker, which will lead to the greenhouse effect gradually but irreversibly intensifying. That is why the theory about the probability of this event is referred to as the clathrate gun hypothesis. According to the original version of this hypothesis, the so-called clathrate gun may cause sudden self-reinforcing global warming, and it may take the process less than an average human life to be completed. It is suggested that such decomposition of methane hydrates may have caused sharp changes in the global ocean and the Earth's atmosphere in the past, and mass extinction events were the direct consequences of these processes. The chief result of methane release is a temperature increase. This is posited to be the decisive factor of a temperature growth by 6 degrees Celsius during the Permian extinction. In addition, there are theories suggesting that following methane release, the level of available oxygen in the atmosphere will drop, which in itself is an alarming prospect. In fact, the content of CO2 in the atmosphere today has reached an all-time high, and it keeps growing exponentially. So if this scenario were to run its course in this manner, clathrate methane destabilization may turn into an irreversible, self-reinforcing mechanism that would cause temperatures to rise to dangerous levels. As a result of a substantial and continuous temperature increase in the ocean, deposits lying under the bottom will heat up to a point sufficient to start the process of decomposition of the deepest layers of clathrate methane. It should be mentioned that it will take several millennia to get this process started. Recent studies in the Siberian Arctic revealed that even at this point millions of tons of methane have been released, probably due to permafrost ruptures at the sea bottom. Following this, in some areas methane concentration has grown hundredfold. Methane release in the modern world used to be estimated at 0.5 megaton a year. Today, not less than 1,400 gigatons of carbon in the form of methane is trapped underwater below permafrost in the Arctic. Incidentally, permafrost thawing would occasionally occur in the history of our planet. That is why some researchers claim that the processes taking place today can hardly be detrimental to mankind in any way. Still, human impact on the environment should be monitored at all times, and we will always have to have an eye on our activities and make sure that they do not grow more and more damaging to our nature. The Bermuda Triangle is an area in the Atlantic located off the southeastern tip of Florida. Part of the triangle's water zone is in the Bahamas. The area itself is between Miami, the Bermudas, and Puerto Rico. The area covers over 140,000 square miles. Navigation in these parts is extremely difficult on account of innumerable shoals. Besides, frequent cyclones and storms originate here. The turbulence of the waters here may be explained by the fact that the Bermudas are located in the open ocean, and should a storm simultaneously begin in the northern and southern parts and near the coast of Florida, the three storms will collide, thus generating enormous waves. All sorts of vessels were wrecked in these waters throughout the long history of seafaring, and the natural disasters responsible for these accidents are quite ordinary and are very well known to mariners who often have to face them in the open ocean. For example, the 165-meter-long Cyclops we've already mentioned is likely to have fallen victim to lateral waves. There are several facts in favor of this version. To enhance the capacity of the ship, its bottom was constructed flat, which made it vulnerable to the assault of lateral waves. It is also possible that the vessel was smashed by a single, gigantic wave. These may suddenly appear even in fine weather, as opposed to regular waves. It is these natural phenomena that are likely to have caused this and other vessels to perish in these waters. As waves of this kind catch up with the ship abruptly and without warning, the crew are too taken aback to send out a mayday call in the nick of time. But even one story of this kind was enough to sparkle instant interest in the newly born legend that was to spread across the rest of the world in the blink of an eye. So there was no way journalists could overlook this matter. The second half of the 20th century heralded a stream of unverified information about the Bermuda Triangle in newspapers, and very soon it acquired the reputation we're used to today and is firmly lodged in people's minds as an anomalous, bizarre, mysterious place. Is it such an unfathomable mystery, though? It wasn't only the vanished ships that were the main cause of interest in the area. The most sensational incident was the disappearance of 5 Navy bombers on the 5th of December 1945. On reading this story in a newspaper, you would also most likely not fail to see it as a mysterious occurrence. At first glance, it does appear inexplicable. The flight leader was an experienced pilot, and the flight was taking place in fine weather. The search for the planes revealed nothing, the only evidence of a crash being deciphered radio transcripts of the men. It can be heard that they were completely disoriented and had no clue as to their whereabouts. All their compasses seemed to have failed. But if one looks deeper into the matter, mysticism and conspiracy theories give way to something more down to earth, and eventually a perfectly logical explanation can be found for such air and water accidents. One of the most popular versions is the giant waves theory. These may rise as high as 30 meters. It goes without saying that planes wouldn't be within their reach, but even a truly enormous vessel may easily be sunk by a wave like that. The point is that a storm at sea may persevere for several days. If 2 waves overlap, they get mutually enlarged, and there occurs what is known as interference. That's the special term for this phenomenon. As a result, the size these waves may grow to is mind-boggling, and even storm-resistant vessels may be unable to withstand their crushing force. Unlike with a tsunami, these waves appear abruptly even in fine weather, so it's downright impossible to see them coming. The fact that hardly any debris is recovered after crashes or shipwrecks is accounted for by the nature of the bottom of the Bermuda Triangle. Its relief is one of the most elaborate in the Atlantic Ocean. For one thing, a huge trench traverses the triangle. It is called the Puerto Rico Trench, and its depth reaches 8,742 meters. The length of the trench measures 1,754 kilometers and its width about 97 kilometers. This is the deepest point in the Atlantic Ocean. Besides, the bottom of the Bermuda Triangle is extremely diverse and is rich in continental slopes, shelves, shoals, middle and marginal plateaus, abyssal plains, and deep-flowing straits. This per se doesn't account for the shipwrecks, but it certainly makes any search for wreckage practically impossible. Speaking about the disappearance of plains, the key to the riddle may also lie at the bottom of the ocean and may have to do with tectonics. Seismic activity at the bottom of the triangle may cause magnetic perturbations, which in their turn may cause navigation devices to malfunction. By the way, frequent underwater earthquakes result not only in methane eruptions, but may also generate infrasound, which in its turn interferes with radio waves. This could be why the electronic equipment failed and the pilots lost their bearings. Infrasound is also pernicious for the human psyche. Having been exposed to it, especially for a prolonged period, the pilots and seamen may have lost reason and acted uncontrollably. For example, the mariners may have abandoned their ships or else lost the ability of navigating them responsibly. However, the version that has most evidence has to do with gas eruptions as a result of decomposition of methane hydrate in the fields at the bottom of the ocean. These fields are formed after a great many years of decomposed organisms accumulating on the ocean floor. According to this concept, big methane-rich bubbles are formed on the water's surface. Their density is low to such a point that ships cannot help capsizing and so sink instantly. When methane reaches the surface, water becomes saturated by bubbles of gas, and a ship loses its buoyancy. On several occasions, geologists observed entire oil platforms submerging underwater as a result of such eruptions. Talking about air accidents, it seems feasible that while floating in the air, methane may cause them to fall. For example, the air density could decrease to such a point that the carrying capacity of aircraft could drop as well, and the altimeters would malfunction. It was experimentally confirmed that a ship really could sink relatively fast following the effect of this phenomenon, provided the culprit gas bubble is bigger than or equal to the ship's dimensions. Interestingly, methane hydrate is to be found in other areas of the global ocean, in the Sea of Okhotsk, for example, and many other places across the planet. Unlike with the Bermuda Triangle, however, those places didn't receive much publicity, as no such outstandingly sensational accidents or shipwrecks took place there. We can't but admit that many of the reports about what happens in the Bermuda Triangle are seriously exaggerated. And ships and aircraft do vanish in places all over the world from time to time. Let's try to sum up all the above mentioned and look at the Bermuda Triangle from a different perspective. If we consider it as an area in the ocean with a high rate of cyclones and storms, the statistical figures on plane crashes and shipwrecks shouldn't really strike us as particularly high. And when people finally get to the heart of the matter in their investigations of the causes of those tragic accidents, we will probably see that there is nothing downright bizarre about it all after all. But while it is still shrouded in mystery, the Bermuda Triangle enjoys keen interest of a great number of people on our planet Earth. First of all, let's dwell upon the terms used in science to refer to such astronomical bodies. The term asteroid was coined at the beginning of the 19th century. It was used to refer to star-like dots that can be seen through a telescope and which differed from planets by their appearance of disks. That was the reason why asteroids used to be classified in the same category as small planets up until 2006, the defining parameter being their diameter, that had to measure not less than 30 meters. Celestial objects falling short of this size are called meteoroids. Astronomical bodies that eventually burn up in our atmosphere fall into the category of meteors, and those bodies that make it to the surface of our Earth or any other large object in space are referred to as meteorites. On impact, most of them have a mass ranging from several grams to dozens of tons. On average, the overall mass of meteorites falling on the surface of our planet every year may reach as much as approximately 2,000 tons. Generally, meteorites enter the Earth's atmosphere at speeds of approximately 50 kilometers per second. As a result of such rapid movement, we're able to observe heated fireballs of intense brightness. On reaching the surface of a planet, a meteorite would have experienced heating and ablation on its way, and its mass would have become smaller than what it was on atmospheric entry. As for tiny celestial bodies with no mass to speak of, they burn up almost completely after experiencing speeds of over 25 kilometers per second. When a meteorite makes it through the Earth's atmosphere, it loses its forward velocity as it decelerates due to air drag. This, in its turn, subsequently changes the trajectory of the fall. For example, if the original trajectory of the meteorite's fall is horizontal, as a result of deceleration on its way, it may drop towards the surface of a planet almost vertically. Simultaneously, the fireball gets dimmer during the process, and the object itself considerably cools down. But if an astronomical body manages to reach the surface of the Earth in the end, it collides with it, and this phenomenon is known as an impact event. As a rule, a crater is usually formed upon impact, and there is a risk of a fire, an earthquake, or a tsunami in the area. An impact event is able to trigger some really disastrous processes. Some theories have it that it is meteorites' infall that is to blame for major extinction events of species in the past. When an astronomical object of this kind collides with the surface of our planet at high velocity, a staggering amount of energy is released, accompanied by powerful explosion processes resulting in the formation of a crater with a diameter by far larger than that of the meteorite itself. For example, the well-known crater in Arizona with a diameter of 1.2 kilometers was formed about 50,000 years ago when the surface was hit by a 50-meter astronomical body with a mass of approximately 300,000 tons. The force of the explosion upon impact was comparable to the explosion of 8,000 atomic bombs of the kind dropped on Hiroshima. Following an impact event, there may appear rock formations as a result of a process known as shock metamorphism, and some mineral deposits like copper and nickel deposits in the Sudbury Basin have come to be thanks to this phenomenon. Meteorite craters may measure up to 500 kilometers. There may even be settlements within their borders. For example, the Vredefort crater located in South Africa was dubbed after the town inside it, with the crater's diameter reaching 300 kilometers. Just to compare, it is about 1.3 of the Chicxulub crater or the Sudbury Basin. The object was formed over 2 billion years ago as a result of the Earth getting hit by an asteroid with a diameter measuring approximately 10 kilometers. Vredefort is considered to hold the second place among the most ancient craters on Earth, and is beaten only by Swaviavi, whose age is about 2.4 billion years and which is thus several hundred million years older. The object is also the largest crater apart from the unexplored Wilkesland crater, with a diameter of approximately 500 kilometers covered by an ice shield in Antarctica. The Wilkesland crater is likely to have been formed on a collision with an asteroid whose diameter measured about 60 kilometers. At first, scientists were unable to determine the date of its formation, but recent studies revealed that the crater's age is approximately 250 million years. It is highly likely that this impact event caused the mass extinction in the Permian period. It would have been dramatic to such a point that 96% of all ocean species and 73% of all land species died out as a result of this collision. However, to date this version has not been confirmed, as exploration of the crater is difficult due to its location. It is worth mentioning that not all meteorites leave giant craters upon impact, and many astronomical bodies hit our Earth with by far less force. The Hober meteorite, for instance, didn't leave any large crater. But it is this object that is the largest astronomical body ever to have been found on the surface of our planet. This object is the biggest piece of iron of natural origin on Earth. As for its mass, it is estimated at 66 tons. The meteorite's volume is 9 cubic meters and its diameter measures about 3 meters. Hober hit the Earth approximately 80,000 years ago, although its discovery was made only as late as in 1920 near the town of Grootfontein, which is situated in the Republic of Namibia in Africa. It was a chance discovery, as neither a crater nor any other signs of the fall were to be seen that would be indicative of the impact. A possible reason for this could have been Hober's deceleration in the atmosphere. The object's surface is smooth and flat, which is untypical of most meteorites, As for its chemical composition, Hobe is a dense metal object with 84% of iron, 16% of nickel, and also traces of cobalt. Even though the meteorite has never been weighed, its original mass is estimated to have been approximately 90 tons. Interestingly, the Hobe meteorite didn't cause much damage to the planet's surface, which is really stupefying. As a rule, the gravity of consequences depends directly on where such an object falls. For example, the meteorite whose fall supposedly caused the extinction of dinosaurs fell in the vicinity of the Yucatan Peninsula, hitting shallow waters in an area where there were gypsum or plaster rock deposits at the time. As a result, large amounts of sulfates were released in the atmosphere, which in its turn led to the prolonged period of global winter. Since the asteroid struck the Earth at an angle of about 60 degrees, a great amount of dust was released into the atmosphere. As for the collision itself, it would have caused a tsunami of about 80 meters. A high-temperature shock wave would have swept across the entire planet's surface, causing wildfires on its way, and particles of dust and soot floating in the air triggered a climate change when direct sun rays rebounded from the dust cloud, not reaching the surface of the planet. This cloud would have persisted for several years. It goes without saying that the chance of a collision of the kind taking place today is infinitely small, as the fall of a large meteorite is a rare occasion. However, man hasn't yet come up with a contingency plan to ensure our safety should a threat of this kind actually materialize. Just to give an example, one of the most dangerous asteroids on a collision course with our Earth is 1950 DA, a small near-Earth object with the highest Palermo rating of the potential hazard of impact. The closest approach with the asteroid is going to take place in 2032, and the odds of its hitting the Earth in the year 2880 are estimated at 1 in 300 at the most. In this case, the human race is going to be affected by catastrophic calamities, such as a global climate change, with a significant part of the biosphere getting destroyed as a result. The diameter of 1950 DA is 1.3 kilometers, and its mass hasn't been estimated yet. The second most potentially dangerous celestial traveler is considered to be the Bennu asteroid, which is estimated to be just 300,000 kilometers away from our planet in the year 2135. The date of its possible infall fluctuates between the years 2175 and 2199. As this is the period when the Bennu asteroid will approach the Earth relatively closely on 78 occasions. But the odds of it hitting us are 1 in 4,000. The asteroid's average diameter measures over 510 meters, and its mass is estimated to be between 60 and 78 million tons. A collision of an object like that with the Earth is tantamount to the explosion of a bomb of 1,150 megatons in TNT equivalent. Just to compare, the most powerful bomb ever tested by humans on Earth was the Tsar Bomba, with a power of about 58 megatons in TNT equivalent. It is quite likely that science will soon find a way of changing trajectories of potentially dangerous astronomical objects heading towards us from the infinite depths of outer space. But before it is made possible, we can only hope that no impact event of such devastating force will take place on our Earth for at least the next 1,000 years. The evolution of life on Earth was anything but linear. There were periods of higher diversity, as well as periods of almost total extinction. This was deduced following the analysis of fossils unearthed at paleontological digging sites. In the past 540 million years, there have been 5 major and about 20 minor extinction events. However, the most global crisis of our planet's biosphere occurred much earlier, approximately 2.1 billion years ago. The first living organisms are posited to have appeared on Earth rather early, approximately but not quite 4 billion years ago. That is about 400 million years after the planet's surface had become more or less suitable for life. Even so, the Earth of that period can't have looked hospitable. Barren rocks, dense clouds, frequent storms and earthquakes, and an atmosphere devoid of oxygen made up of mostly nitrogen, methane, and carbon dioxide. This was the age of primitive microorganisms, archaea and bacteria, most of which used anoxygenic photosynthesis. That is a kind of photosynthesis where oxygen is not produced. Apart from these creatures, it is thought that there were many forms falling in between that couldn't be classified as either living beings or not living objects with a satisfying degree of certainty. About 2.7 billion years ago, there emerged oxygenic photosynthesis, the kind of photosynthesis familiar to us where oxygen is produced. This form is still used by the overwhelming majority of plants and unicellular algae. Anaerobic organisms cannot live in an oxygen-rich environment. That is why ancient algae used oxygen as a weapon. They released it as a byproduct of their life activity, and this waste killed their competitors. This way, algae not only protected their turf, but also spread further to cover larger areas to dwell on. At first, oxygen was spent on oxidation of rocks in habitats of aerobic organisms' colonies. In this manner, oxygen pockets were formed, small areas of oxidized minerals. Gradually, oxygen went on to spread in the atmosphere, oxidizing methane, sulfur compounds, and iron. Not able to exist in an environment rich in oxygen, most anaerobic organisms died out, with those of them remaining around confined to underground pockets where oxygen didn't reach. Thus the tables were turned in the biosphere, with the oxygen-breathing organisms becoming the majority and spreading across larger areas, and the former planet owners forced to remain in some limited areas. With the spread of the new organisms, the content of gases like methane and carbon dioxide in the atmosphere dropped. Methane oxidized, forming water, and eventually carbon dioxide, with the latter taking active part in photosynthesis. All this reduced the greenhouse effect, and the Earth's surface considerably cooled. The so-called Huronian glaciation started approximately 2.1 billion years ago and continued for about 300 million years until the Sun's luminosity and tectonic makeovers had heated up the Earth. This was a time when single-cell microorganisms were evolving extremely slowly, constantly thwarted by an occasional prolonged global ice age. The period has earned a great number of nicknames like the Great Oxidation or Oxygenation Event, Oxygen Catastrophe, and Oxygen Crisis, to name but a few. Even though not really swift, this event was definitely large-scale and global. Practically all the biodiversity of the non-oxygen period was eliminated, and evolution was greatly hampered by global glaciation for a good billion years. However, in the aftermath, there emerged a more energy-efficient method of nutrition. Approximately 540 million years ago, the Phanerozoic eon started, sometimes referred to as the period of visible life. It was peculiar for vigorous evolution of multicellular species, and in fact it is actually still in progress. Many creatures of that age looked really bizarre and didn't resemble any of their today's descendants. Suddenly, about 450 million years ago, some unknown factor abruptly interfered with the active evolution of life forms. The proposed causes include a cosmic gamma-ray burst, volcanic activity, and even a large celestial object impact. As it is, from 25 to 50% of all living beings became extinct within 7 million years. This series of extinction events, dubbed the Ordovician-Silurian extinction, was hard on trilobites, mollusks, and some other marine invertebrates of the time. The late Paleozoic era that followed this extinction event heralded active evolution of flora on land. The first amphibians and reptiles emerged in that time too. Fishes were actively evolving, establishing their dominance in all freshwater and saline bodies of water. Approximately 372 million years ago, the so-called Devonian extinction started. It occurred in several stages that were alternately followed by comparatively peaceful periods. Peaceful they may have been, but even so, the extinction rate of species was higher than average. The most likely reason for this extinction is posited to be this. Land plants of the time sported long and powerful roots, which enabled them to extract nutrients from much deeper down in the soil than before. When water seeped through soils that were loosened by plants' roots, great amounts of nutrients were washed into the ocean. As a result, algae were positively thriving there in the abundance of food and light. The rotting of these algae reduced oxygen dissolved in the water, and the organisms inhabiting the sea bottom were simply smothered with nothing to breathe. In the aftermath, about 70% of the marine species at that time are estimated to have died out, including practically all species forming coral reefs. This triggered global irreversible changes in the biosphere of the global ocean. Many genera and families vanished completely, and the vacated space was filled by others. In the Carboniferous period which followed, tree ferns exploded in numbers all over the planet's surface. Also, there emerged gymnosperm trees and conifers. It is in this period that rich deposits of coal were formed, which is still widely used by mankind in various industries. Speaking about the fauna, this was the time when insects thrived. That's when the giant millipede Arthropleura was around, which measured 2.5 meters, the Meganeura, a giant dragonfly with a wingspan of up to 1 meter, and the Pulminus scorpius, a scorpion measuring 70 centimeters. The insects were of these unbelievable sizes on account of exceptionally high concentrations of oxygen in the atmosphere, which at that time reached a staggering 35%. The Permian-Triassic extinction event, also informally referred to as the Great Dying, occurred about 251–253 million years ago, marking the transition from the Permian to the Triassic period. It proved to be the most massive and global in the entire history of multicellular life. Diggings show that up to 95% of marine species and up to 70% of land species vanished from the face of the Earth as a result. Interestingly, this disaster was rather swift by geological standards. It took just up to 200,000 years. Later, it would take not less than 50 million years for biodiversity to recover for land species and about 100 million years for marine species. Trilobites, a great number of marine invertebrates and microorganisms, were on the verge of extinction. Insects shrank in size. They stopped looking like horror film creatures on the loose and instead assumed an appearance of today's tiny and numerous creatures. The reasons for the Permian-Triassic extinction event still haven't been established with certainty. Among the proposed hypotheses, we may single out robust volcanic activity as one of the most likely ones. Others worth mentioning are a collision of our Earth with a large celestial object, climate change, and active methane emissions following biological or tectonic activities. There is no single answer to this question yet. In the Triassic period, which followed the Permian-Triassic extinction event, vertebrates vigorously evolved. This is when archosaurs emerged, the prehistoric saurians, crocodiles, and dinosaurs were to evolve from. The Triassic period also produced first mammals, although they were not so widespread at that time. About 200 million years ago, the Triassic-Jurassic extinction event began, sometimes called the End-Triassic extinction. Having lasted for approximately 10,000 years, it marked the transition from the Triassic to the Jurassic period. The event claimed about half of known species on the Earth of that time. They included various reptiles and amphibians that vacated a number of ecological niches. This allowed dinosaurs to establish their dominance on the planet and sustain it for the next 130 million years. Incidentally, the reasons for the End-Triassic extinction event are not known either. And in fact, there isn't a single hypothesis today that would sound sufficiently convincing. The Jurassic and Cretaceous periods that followed the Triassic-Jurassic extinction event were the times when dinosaurs thrived and flourished. But these giant saurians were not the sole inhabitants of our planet at the time. This is when the forefathers of today's birds, flowering plants, and corals evolved, as well as small, furry, warm-blooded animals, mammals. Even though these small creatures didn't look quite as impressive compared to tremendous dinosaurs in all their glory, they firmly held their ecological ground and steadily progressed in their evolution. Mammals got their chance at the end of the Cretaceous period, that is about 66 million years ago. What occurred then was the most well-known and a rather large-scale mass extinction event referred to as the Cretaceous Tertiary extinction event. According to the first and most popular hypothesis, the extinction was caused by a giant celestial object impact. Everyone would have heard of a meteorite supposedly killing off all dinos. Nevertheless, there is no hard evidence in favor of this version. Either way, the upshot was that all dinosaurs died out alongside a great number of conifers, algae and mollusks. The Cretaceous-Tertiary extinction event heralded the beginning of a new geologic era, the Cenozoic, which is still in progress. Throughout this era, mammals, birds and flowering plants have been actively evolving and spreading across the Earth. Mammals settled all over the planet, inhabiting it literally everywhere, from tropical areas to ice caps at the poles, and from the depths of the oceans and the planet's interior to air currents up high. Eventually, evolution produced mankind. Even though you would expect people today to be enlightened enough, there are still those who do not believe in evolution. However, the theory of evolution is not something to believe in, it is a scientific theory based on facts. The theory of the evolution of species has come a long way and has undergone serious revisions since its original version proposed by Charles Darwin back in 1859. Still, the basic principles of the theory are the same, and to date, the theory of evolution is the only serious scientific theory that accurately describes the process of the evolution of species and the origin of new creatures. According to some scientists, we are now living in the epoch of the sixth mass extinction event. They also call it the Holocene or Anthropocene extinction. Thousands of species have died out in the past 10,000 years. Around 900 species have vanished from the face of the Earth in the past 500 years. Today, about 40% of amphibian species and 25% of mammal species are under the threat of extinction, and it looks like one of the chief reasons for this is human activity. Will humanity be able to tackle this threat? Will life go one step further up the order, as it was always the case after every major mass extinction event? There is no way of knowing it now. The Earth's biosphere boasts a great potential for recovery and evolution, which by no means implies that it doesn't need our care. After all, the Earth is our only home. Large objects do approach our planet now and then. For example, on the 14th of November 2020, asteroid 2020 VT4 with a diameter measuring about 10 meters passed our Earth at a distance of 383 kilometers from the surface. That is below the International Space Station and most satellites. Even though known potential threats are monitored by scientists at all times, the problem is that most asteroids are rather dark objects, whose dimensions are quite modest by space standards, which makes them hard to detect. However, an explosion caused by an impact of a celestial body with a diameter of just 10 meters would be tantamount to the atomic bombing of Hiroshima. It may not leave any radioactive waste, but a blast this powerful would wipe a little town right off the face of the Earth. An asteroid with a diameter measuring 50 meters, that is as big as a modern multi-story building, would unleash a power of several dozen kilotons on impact, which would be enough to raise an entire city almost to the ground. If an asteroid this large were to fall into an ocean, it would cause a tsunami reaching up to 10 meters, which would wreak destruction all the way it went, traveling for hundreds and thousands of kilometers from the site of its impact. Were this asteroid's diameter to measure a kilometer or so, it would cause mass destruction throughout an entire continent. The force of the explosion on impact could reach as much as thousands of megatons and TNT equivalent, and its consequences would haunt the planet for many years to come. It is highly likely that the human civilization would not survive a calamity of this scale, nor would other living creatures, with the only exception of protozoans and exceptionally enduring organisms. Mass extinction events did take place in the history of our Earth, the most notorious of them, Cretaceous-Tertiary extinction event, about 66 million years ago. It is posited that dinosaurs and a number of other species died out as a result of it. As for the most large-scale mass extinction event, it took place approximately 251 million years ago, coming in between the Permian and the Triassic periods. Based on results of paleontological diggings, It was estimated that about 90% of sea species and 70% land species died out as a result. One of the things that caused both of these dramatic calamities is believed to be the fall of a large asteroid. Today, the number of potentially dangerous objects is estimated to be in the region of 1.5 to 2,000, although this number may reach 4 to 6,000 according to the data provided by the WISE telescope. Since they're so small and dark, these celestial objects are rather hard to spot. For example, the size of the asteroid dubbed 2008 DC3, which burned up in the atmosphere just above Sudan in 2008, was anything from 2 to 5 meters. It was spotted just 20 hours before it would have impacted the Earth. Fortunately, nobody was hurt. There is a special rating scale known as the Palermo scale. It is a generalized scale reflecting potential impact risk posed by this or that celestial body, which takes into account the body's kinetic energy and the probability of hitting the Earth. The higher the value, the bigger the threat to our planet. If a body's Palermo scale value is below -2, this body is practically safe. Asteroids with values between -2 and 0 do not pose any immediate threat, but require monitoring at all times. As for objects with a value above 0, they are realistically dangerous for the Earth. At this point, there isn't a single celestial object out there with a positive Palermo scale value, and there are only 2 asteroids in the yellow alert zone, that is, their value is between -2 and 0. Both of them fall into the category of the Apollo asteroids, celestial bodies whose perihelion lies closer to the Sun than the Earth's aphelion, and whose orbital semi-major axis is bigger than that of the Earth. Thus, these objects cross our planet's orbit from the outside. The Bennu asteroid, designation 1999 RQ36, with a potential hazard index value -1.69, poses a smaller threat of the two. In the year 2135, it will find itself just 300,000 kilometers away from the Earth, which is slightly closer to us than the Moon. Bennu's average diameter measures approximately 500 meters, and the asteroid's mass is anything between 60 to 78 million tons. If it were to collide with our Earth, the resulting explosion would be tantamount to about 1,000 megatons and TNT equivalent, which would almost certainly cause major catastrophic disasters all over the planet. In 2016, NASA launched the OSIRIS-REx probe to Bennu in order to obtain samples of the minerals making up the asteroid. The probe is scheduled to get back to the Earth in 2023. The more hazardous of the two asteroids is 1950 DA, with a Palermo scale value -1.42. Today, it has the highest probability of hitting our Earth. Its diameter measures about 1.3 kilometers, and its mass can be anything from 2 to 4 billion tons. 1950 DA's orbit is elongated and elliptical, and it crosses the orbits of our Earth and Mars. 1950 DA's closest approach to the Earth is expected in 2035, but a hazardous approach will take place only as late as on the 16th of March 2880. What would await us if the asteroid did impact the Earth? Let's assume no preventive measures have been successful to deflect this body and the disaster is inevitable. An enormous chunk of rock with a diameter almost 1.5 kilometers and a mass that could be 2 to 4 billion tons heading towards the Earth at a speed of about 14 kilometers per second. This would be the speed of 1950 DA at the moment it hit the Earth if an impact event did occur, as estimated by NASA. Of course, part of the matter making up 1950 DA would burn up and disperse in the atmosphere as the asteroid slowed down, and the main body would be likely to break up into several large rocks and a great number of small bits. Depending on their size, each of them would cause an explosion of not less than 20 kilotons on impact with the Earth's crust. That's the average power of a modern nuclear bomb with a comparatively modest charge. The overall power of the explosions would most likely be over 1,500 megatons, with the bombarded area larger than that of Europe. All constructions within the radius of 300 to 500 kilometers would be razed to the ground, and even reinforced underground bunkers wouldn't guarantee enough safety. The energy of the shock wave would allow it to sweep around the Earth several times while gradually slowing down and bringing more destruction on its way with every lap. If the asteroid were to fall into an ocean, a giant tsunami would rise 40 meters or higher. Tsunamis normally travel for thousands of kilometers, and as they go, their destructive forces practically don't diminish. Therefore, coastal areas of the continents lying near the site of the impact would be submerged in water, with cities and villages effectively wiped out. Multiple impacts of bits of rock would raise tons of dust in the atmosphere. Winds would scatter these dense clouds all over the sky, and most sunlight would not reach the planet, which would cause a sharp temperature fall. This phenomenon is known as nuclear winter. It is highly probable that an impact of this scale would affect not only the crust, but the mantle as well. The shock wave would wake up volcanoes, and they would erupt all over the planet, which in its turn would cause the second wave of tsunamis and earthquakes. Tons of ash released in the atmosphere would contribute to further temperature drops. There is quite a popular belief that after an asteroid hit the Earth, it would affect its orbit or orbital period. This would lead to dramatic climate changes and even render the planet completely incapable of sustaining life. However, according to some estimates, an impact of even the biggest asteroid in the solar system would not be enough to do so. An object realistically able to noticeably change the Earth's orbit should be as big as the Moon or Pluto at the very least. Be it as it may, if it were to happen, the consequences of an impact of this scale would be much graver than just a change of orbit or orbital period. The potential impact risk of 1950 DAs hitting our Earth is just 0.012%. There is no room for complacency though, as the impact probability may rise following a change of the asteroid's orbit as a result of collisions with other celestial objects that may well take place. For a long while it was believed that the humanity hadn't advanced enough to prevent any hazards of asteroid falls. All we could do was just observe potentially hazardous objects. Actually doing something about them, like destroying an asteroid or changing its orbit, was confined to science fiction films and books. However, science doesn't stand still. Even in 2004, when a threat posed by Apophis was considered grave enough, it was proposed to cover its surface with light-reflecting film. This way, sunlight pressure would change the asteroid's orbit. Other suggestions included nuclear bombings, as well as special power thrusters powerful enough to shift orbits of celestial bodies. In 2018, NASA, in collaboration with SpaceX, approved the DART program, whose aim is to deflect the asteroid's trajectory by making it collide with an artificial spacecraft. The binary near-Earth asteroid Didymos, made up of two components with diameters measuring 800 and 150 meters, is the target for the DART demonstration. The launch of the spacecraft is planned for 2021. Celestial bodies in the solar system may be closely monitored, but there is always a risk of some body previously unknown to us arriving from the galaxy's outskirts and heading towards the Earth. Orbital periods of some comets and asteroids around the Earth may last hundreds and even thousands of years, and their small sizes and dark surfaces render these potentially dangerous visitors barely detectable. Still, the odds of such a disaster as an impact event are extremely small. And in fact, there are many more dangers that may befall the human race on our own planet. In this film, we have talked about a few phenomena mankind has come across in our comparatively short history. But even with all the information gathered by now, it is impossible to say with absolute certainty that science has made any progress in getting to the heart of the processes taking place on our Earth. The blue planet is an organism in its own right, and it has its own unique features. It's going to take us hundreds of years of meticulous research to figure it out completely. And while the process of investigating our planet is underway, I'll do my best updating you on the details on the Cosmo channel. Let's keep in touch.